Hello everyone, I'm Srivarsha Kulkarni from Team Chitti. I'm here to present our project Integration of Vision-Based Robot Manipulation using ROS for assistive applications. Our objective is to build a six-wheel rover on which a vision-based robotic arm is placed. There are several stages in this process. Stage 1 is setting up the GCS. GCS is nothing but ground control station. It is a software used to control unmanned vehicles. There are several GCS softwares such as Mission Planner, Q Ground Control, etc. But here we are using Mission Planner as it is more suitable for our hardware. Here our vehicle is rover and we have simulated our rover in Mission Planner and we have assembled our rover using hardware components and we have tested our rover in GPS and non-GPS environment and we have installed ROS and MAVROS in Jetson Nano and our next stages are robotic arm simulation and assistive applications. Pixoc, it is a microcontroller used to control unmanned vehicles. It is an open source autopilot platform which helps in controlling unmanned vehicles. It contains sensors such as GPS, compass, accelerometer, etc. Compass is used to get directions and accelerometer is used to measure speed and position of the vehicle. Pixoc is physically installed in the vehicle and connected to its various sensors and components such as GPS receiver, compass and motor controllers. And we then connect this Pixoc to the ground control station, that is laptop, running a GCS software such as Mission Planner, and then we calibrate our Pixoc to get the directions of the rover, and Pixoc receives the data from the sensors and uses this data to calibrate the rover position, orientation and the velocity. It then sends control signals to the rover motor controllers to adjust its speed. And next is GPS module, which is used to determine the rover position in three dimensions based on signals received from the GPS satellite. It can also be used to create a map of vehicle surroundings. And Mission Planner, it is a software in which we can give the plan in which the rover have to move. We give the waypoints where the rover have to move in those waypoints. There are few settings like setup and configuration. In configuration, we have installed a rover firmware, and in setup, we have calibrated our rover. We have done axle calibration and compass calibration. Here we have to check for the serial ports and connect our rover to this Mission Planner using telemetry or USB cable. We have used 2 by 32 motor driver, saber tooth motor driver, which consists of two channels, and each channel experiences 32 amperes of current. Here each channel is taken as consists of three motors, and these three motor experiences 32 amperes of current, which helps in the rover motor movement. ROS is an open source framework for building and developing robotic software. It is generally known as Robot Operating System, which provides collection of libraries and tools that help developers create complex and modular robot applications. Mavros is a ROS package that provides a ROS interface to Mavlink-based autopilots such as Pixoc Flight Controller. It allows ROS nodes to communicate with the autopilot over a serial interface or a network connection. Jetson Nano. It acts as the brain for our rover. It helps in processing the image of the object captured by the camera of a running object. If there is an obstacle while moving to that object, the rover takes a diversion and moves towards the object. And this is a rover on which we place Jetson Nano, robotic arm and camera. So camera captures the image of the object. If the object matches with the input given by the user, the rover moves towards the object and robotic arm picks the object. There are several applications such as industrial applications, and it can also be used for the people suffering from disabilities and agricultural applications. But here we are designing a rover for industrial applications because in few place industries there are few places where humans cannot enter into those places. We send this rover by feeding the object, and if the camera captures the object matches the user input, the rover moves towards the object and the robotic arm picks the object. Here we have used 6 DOF robotic arm and we have used YOLO v3 algorithm which helps in object detection. Thank you.